Good morning, students. Today we are going to discuss the chapter Mechanical Properties of Fluids. It is chapter 10. Now, what is fluid? Fluid is the state of the material under which the material flows. So you can say liquid and gaseous can be considered under the headline fluid. So let me read out what we have written in the board. Fluid is a substance that flows under the action of an applied force and does not have a shape of its own. So it's a very simple one. It means the material which flow and does not acquire any shape or does not have any definite shape, you can say, and it acquires the shape of the container. Basically here we'll consider liquid as a fluid. We are not going to consider the gas. Now liquid exert pressure, gas also exert pressure, so you can say fluid also exert pressure, even solid also exert pressure. So let me define what is pressure. Pressure is defined as the magnitude of the force acting perpendicular to the surface of an object per unit surface area of the object. Let me repeat. Pressure is defined as the magnitude of the force acting perpendicular to the surface of an object per unit surface area of the object. So pressure is nothing but force by area. So if a constant force of magnitude capital F acts normally on a surface area capital A, then pressure acting on the surface is given by P equal to F by A. F is the force and A is the area. So SI unit of pressure is your Newton per meter square. And the dimension for pressure is your, for force it is M1 L1 T minus 2, that is your MA, and area is your L2, so M1 L minus 1 T minus 2. So the dimension of pressure is your M1 L minus 1 T minus 2. Now based on the definition of the pressure, we'll try to state Pascal's law. So it is after the name of the scientist regarding the strange properties of fluid or strange properties of the liquid. Now what it says, the pressure applied to an enclosed liquid is transmitted undiminished to every portion of the liquid and walls of the containing vessel. Let me repeat. The pressure applied to an enclosed liquid is transmitted undiminished to every portion of the liquid and walls of the containing vessel. Okay. Now how can we explain this Pascal's law? For that we have to go through this figure. Now you see, you do have a container and the container contains liquid. Now it has 4 outlets and these outlets are closed by the piston of different area of cross section. So here what is done, we have applied force F1 on the piston whose area is your capital A1. So when you apply force on the piston, then definitely a pressure generates and that pressure disturbs the liquid, or you can say that pressure moves through the liquid. Now as a result what will happen, these pistons are just fixed on the outlet. So when you apply force on the piston whose area of cross section is your A1, then the pressure transmits through the liquid and it exerts pressure on the walls of the container. Now the walls have 3 more pistons. So as a result what will happen, due to the pressure the other pistons moves outside. So piston of area A2 moves with the force F2, piston of area A3 moves with the force F3, piston of area A4 moves with the force F4. So these are the movement with a different force for different piston with different area of cross section. So as a result you will get pressure corresponding to the pistons of different area of cross section. So as per the Pascal's law, it says that what pressure you have applied on the liquid, with the same amount of pressure the other piston moves out irrespective of its area of cross section and the force. So this is the statement. F1 A1 is the pressure applied on the piston whose area of cross section is your A1. F1 is the force and A1 is the area of cross section. So this pressure has numerically equal to the pressure experienced by other piston due to the liquid that moves with different forces. So F2 by A2 equal to F3 by A3 equal to F4 by A4. So this is quite strange property. Actually, what happened, due to the movement on the way, the pressure much diminished, but here the pressure does not reduces when it moves through the liquid. So this is the strange properties of the liquid. So the pressure transmits with undiminished magnitude in all direction. Undiminished magnitude. So what we have written in the statement, you see, the pressure applied to an enclosed liquid is transmitted undiminished to every portion of the liquid and walls of the containing vessel. Now let me define this topic, pressure exerted by liquid column. Now you see, you do have a container, and on the container we have considered a cylindrical element, liquid element, whose height is your h and area is your a. Now definitely weight due to this liquid column can be defined by F equal to mg, and mass is related with the density, volume into density. Volume is your A into H, so AH rho. So you can say force is equal to AH rho G. So we have got force exerted by the liquid column on the base of the container, and the corresponding pressure P equal to F by A. So A we have got here, F we have got here, AH rho G. So AH rho G by A, so you will get H rho G. Now the next topic, that's a very important one. So pressure, ultimately you are getting P equal to H rho G in case of liquid. H is the height of the liquid column, rho is the density, and G is the acceleration due to gravity. Now a variation of pressure with depth. So here in the container we have certain amount of liquid, and we have considered an element, liquid element you can say, cuboid shape. So what happened, the liquid which is available above the element exerts force F2, the liquid which is available below the element exerts force F1, and also the lateral force is also there, but we are neglecting because the condition liquid is at rest and also it is in equilibrium. So height of the element is your delta x we have considered. Now if we consider the system is in equilibrium, so F1 equal to F2 plus W. W is the weight of the liquid element that acts downward. Now in terms of area and pressure, if we consider the area is your A in top as well as bottom, so P1A equal to P2A plus mg, weight is nothing but the mg. Now P1 minus P2 within bracket A equal to mg. So m is the mass of the element, so mass equal to rho A delta x, rho into volume, so g. So if we cancel out A, then it comes out to be your P1 minus P2 equal to rho delta x g. Now if we consider delta x is 0, it means we are considering a particular level, then you will see that P1 and P2 is identical. It means the pressure is same at all points at the same depth in the liquid. If you consider delta x equal to 0, it means we are considering a particular level, and at that level the pressure remains same. So the conclusion part of this topic is that on the same level pressure remains same. So please go through and try to find out your doubt or clear your doubt. More we will study, more doubt will come out. If you don't study, then no doubt, everything seems to be fine. But in exam, it's very tough for you to write the answer. So be careful and do study. Thank you.